We're finding zeros and behavior of a polynomial function. Back again. Quick 10-minute video. This one combines so many concepts. You got parent functions and end behavior of a polynomial function. You've got factoring techniques, synthetic and long division. Holy schmoly, how to find zeros of a polynomial function, how to find x and y intercepts. Polynomial functions are smooth and continuous. There's a lot going on here. So this one combines a lot of different smaller concepts into one example. And of course, there are other variations of these examples, get a little more sticky, like what happens when you have a double zero. In other words, bing, bing, it bounces off of the x-axis. That gets into a little more, fishy circumstances. But I will say that with this example, there's a couple of pieces in it that I really thought was interesting. So like I said, I could sit here and make 10 videos on 10 different polynomial functions, but they all have certain similarities, and you got to be careful of contradictions, because when you have something that's contradictory when you're trying to graph it, you know you've done something wrong. It's not the graph. In this case, it's you or me or maybe us. But let's just go ahead and start off. What I have is f of x equals x cubed minus 13x minus 12. Now there's a couple of these pieces that are real quick that we should get right from the get-go. For example, the y-intercept. Define the y-intercept of a polynomial function, like in this case, or define the y-intercept of any function. You let x equals 0. So if x is equal to 0, we've got negative 12. So all of a sudden, we already have 1 point. We have negative 12. Whoops, I am so sorry. We have let x equal 0, which is why I write it out, 0, negative 12. So that gives us 1 point already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So we've already got the y-intercept. Very easy to find. End behavior. So when we look at this function, we ask, who's your daddy? Who's your daddy? I think it says x equals x cubed. Oh, it is. Yeah, he looks just like you. So it's f of x equals x cubed for obvious reasons. The highest degree right there. Look at that. X equals. So we know what you look like. You look like this. So all of a sudden, as x approaches infinity, as x gets larger and larger and larger, our y values are going to model this parent. They're going to get larger and larger. So in other words, this graph is going to do something like this, and it's going to do something like this at the very end. Now, it's going to do something, obviously, in between, but this is kind of just giving you a quick idea that, hey, we're going to look, something fishy is going to happen here, so it may not look the same, but the end behavior of the function eventually, as x gets larger and larger, this bad boy is going to skyrocket. As x gets closer and closer toward negative infinity, the y value is going to drop to negative infinity as well. So let's spend our time today finding the x-intercepts. Now, I'm not going to get deep into Descartes' rule of signs and all that other good stuff. And the fact that the leading coefficient of this polynomial is 1 makes this a really easy example. Because what I'm saying is, if I had x minus 2 times x plus 3 and use FOIL on this, this is x squared, the outer and inner combine together to give you x, and there's minus 6. So what happens here is the leading coefficient's 1, so all I needed to do was think of two numbers that multiply together to give me negative 6, but add together to give me 1 to factor it. But when I go this direction and I'm just multiplying it out, expanding it, I notice that negative 6, negative 2 and 3 are factors of negative 6. So what I want to do is recognize that this ends in negative 12. So if I'm going to write this as a series of the product of several binomials, I want to make sure that all those final terms in each binomial, that constant, they're all factors of negative 12. So I really need to zero in on factors of negative 12. Now granted, we could have some irrational issues here and so forth, but I picked out an easy example just for us to get our feet wet. So factors of negative 12. We have plus or minus 1, plus or minus 2, 3, 4, 6, and 12. Whew, there's quite a few of them. There's 1, 2, 3, 4, 5, 6, and then 6 more negatives. That's 12 different possibilities. So what we do is we're trying to find the zero of this. So I'm going to use synthetic division. So what happens here, here's x cubed. There's no x squared, so we let that be 0. There's our x to the first and our constant. And what we're looking for is a 0 right here in this position, so that this value will be a 0 for us. So let's just pick one. I'll pick 4. Come on. So synthetic division. 1 times 4 is 4, add them together. 4 times 4 is 12, add them together. Negative 1 times 4 is negative 4, add them together. Rats! 4 does not work. So I'm going to just make sure I don't use you again. Positive 4 does not work. So let me try another one. Maybe you're saying, well, try negative 4. Okay? So this will be 1 times negative 4 is negative 4, add them together. Negative 4 times negative 4 is 16, add them together. 3 times negative 4 is negative 12. Rats! That one doesn't work. Man, I was almost sure. Let me double check. Negative 4, add it together. Negative times a negative is a positive. Add them together 3 times. No, that doesn't work. Well, phooey. So let's mark off all of those. All right, let's try one more. Well, we're going to keep trying until we get a 0. Let's try 1. That's nice and boring. Oh, try 1 right there. So 1 times 1 is 1, add them together. 1 times 1 is 1, add them together is negative 12. Negative 12 times 1 is negative. That doesn't work. Rats. Ooh, let me try negative 1. Come on, pick me a winner. So 1 times negative 1 is negative 1, add them together. Negative 1 times negative 1 is positive 1, add them together. Negative 12 times negative 1 is positive 12. Yay! I got one of my zeros. Negative 1 is one of my x-intercepts. Woohoo! Awesome. So now what I recognize is that f of x, which is this trinomial, is now equal to x plus 1 times, let's go backwards, that's the remainder, constant x squared minus x minus 12. All right? So, what happens here is we have x plus 1. Remember, if negative 1 is a 0, x plus 1 is the binomial factor. And let's see if we can factor this. This becomes x minus 4 times x plus 3. But I thought we tried 4 a while ago. Let's go back in time. When I tried 4, holy cow, I thought I did it right. So let's see. When I tried 4 a while ago, I said 1 times 4 is 4, add them together is 4. 4 times 4 is 16, add them together is 3. 3 times 4 is 12, add them together equals 0. Rewind this video and notice if you see the mistake that I made. Because even if you make a mistake and you go on and find another one, you'll eventually come back and find the right one. So go back, watch the video again, and say, were you screaming at the screen and said, oh, wait, you're making a boo-boo? Or did you just go along and watch the video? Because notice that, hey, 4 did work. And a while ago, I had convinced myself, and hopefully not many of you, that it didn't. So here we go. There's our, and like I said, keep in mind that if 4 works, x minus 4. So had I found 4 first, then the remaining trinomial would have factored into these pieces. So look at this. I now have my x-intercepts as being negative 1, which we already graphed, x equals 4, which I will graph right here, and then x equals negative 3, which is right here. And keep in mind, with my end behavior, this goes out that direction. Right here, this goes down that direction. Now what's going to happen here? This is going to go up and eventually come back down. We've got to go from here to this point. Now it may continue to go down and drop a little further and eventually come back up again. But that is a really nice sketch. Now how far does this go up and how far does this go down? Believe it or not, sitting in Calc 1, you'll be able to easily answer these questions. Notice I didn't use concepts of symmetry or anything like that. I just went through this problem, found the y-intercept, the end behavior, and then I used synthetic division to help me factor this. Synthetic division is a good, nice factoring technique. And the trinomial that resulted once I found that first zero, ended up giving me a nice trinomial that I could factor really easily to find those x-intercepts. So, hope I didn't confuse you too much, but sometimes you really need to pay close attention to what your instructor's doing, because they make mistakes and they go right on with it. See if you catch it. Try. Verify that 4 works. Rewind the video. Catch my mistake that I made. Hope you enjoyed it. Stay on your toes. Finding in behavior and x-intercepts.